So the Marine Biology Lab has been doing surveys of coral reefs around the UAE and other countries in the Gulf for the last 5 years. Typically what we do is we expend many man-hours by going out and doing this sampling. So you have to get a boat.
Every time we go out on the boat, we have to take a minimum of 1 boat driver, and then if we have people in the water, you have to have another minimum 2 people.
Put out these transect tapes. You spend a lot of time in the water.
Then you've got dive gear, which has an inherent cost of filling the tanks, maintaining all of your BCD, your regs, all that kind of stuff.
And all of that has costs associated with it. The financial cost of actually putting people in the water. There's also obviously health risks with people doing diving activities.
Every time you then go out, the cost mounts and mounts and mounts, right?
Now, in a lot of places, what they've started doing to reduce the costs that are associated with having scientists go out and do all of this field work is they try and use what's called citizen science. So they get members of the community who are already out there to collect some data while they're out there, but it does have limitations. The data that you're getting there has reliability issues because it's basically what you're doing is you're relying on individuals who don't necessarily have proper training to collect data in a standardized format. If there's a means by which we can go out and actually collect the data using a standardized format, that solves that problem.
The reefRover is going to be the first widely available, fully autonomous underwater vehicle. Our goal is to bridge the gap between community-level monitoring and scientific research. Essentially what it's going to do is it's going to swim right above the coral reefs, taking a continuous stream of pictures that can later be stitched together to create a map of the underwater world like none other. We want to make it so that anyone can use it, so that the citizen scientists of the maritime community can make a real contribution to the field of marine biology. Essentially, all they have to do is throw it in the water and the reefRover will take care of the rest. We're going to essentially crowdsource scientific research, and with our autonomous vehicle, we can guarantee high-quality data.
When developing the reefRover, we need to find an ROV that's fast, light, maneuverable, and easily accessible. That's where the Open ROV comes in. Open ROV is open source, meaning it's hackable and adaptable to the mission at hand.
Right now, we're faced with the challenge of adapting already existing autopilots for the reefRover's use. We've decided to create entirely new firmware that works on already existing autopilot controllers. By taking in data from onboard sensors, the reefRover will be able to guide itself through uncharted waters autonomously.
Once we collect the data, we'll organize it in a user-friendly database. The researchers will be able to navigate through the filters such as geographical location, presence of coral reefs, site name, and so on. Next, we want to add a third dimension to it. Just imagine having a 3D representation of the Arabian Gulf seabed. We're going to make it happen.
We're breaching this barrier between community monitoring and research monitoring. And what we're going to do is we're going to bring this research monitoring to the community.